Position on an object over time. Motion is described in terms of displacement, distance, velocity, acceleration,
1, 2, 3, go.
acceleration, time, and speed. Motion of a body observed by attaching a frame of reference to an observing and measuring the change in position of the body relative to that frame. If the position of a body is not changing with respect to a given frame of reference, the body is said to be at rest, motionless, immobile, state nyo sa cut.
Go.
Stationary or to have constant position. An object motion cannot change unless it is acted upon by a force. As described, momentum relates to the object mass and velocity, and the total momentum of all objects in an isolated system does not change with time as described by the law of conservation of momentum. As there is no absolute frame of reference, absolute motion cannot be determined. Just everything in the universe can be considered to be moving. More generally, motion it is concept that applies to object, bodies, and matter particles, to radiation field, and radiation particles, and to space in curvature and
Go.
space-time. One can also speak of motion of shape and boundaries, so that the motion in general
Go.
signifies and continuous change in the configuration of a physical system. For example, one talk about motion of a wave or about motion of a quantum particles, where the configuration consists of probabilities of
Game.
bilang ka?
Go na. Go.
Of or copying specific position.
Physics, potential energies, energy possessed by a body by virtue of its position relative to others, stresses within itself, electric charge, and other factors. Common types include the gravitational potential energy of an object that depends on its mass and its distance from the center of mass of another object, the elastic potential energy of an extended spring, and the electric potential energy of an electric charge in an electric field. The unit for energy in the International System of Units is the joule, which has the symbol I. The term potential energy was introduced by the 19th century Scottish engineer and physicist William Rankine. Also, thus links to Greek philosopher Aristotle's concept of potentiality. Potential energy is associated with forces that act on a body in a way that the total work done by these forces on the body depends only on the initial and final positions of the body in space. These forces that are called potential forces can be represented at every point in space by vectors expressed as the gradients of a certain scalar function called potential.
Of potential forces on a body that moves from a start to an end position is determined only by these two positions and does not depend on the
Go!
trajectory of the body. There is function known as potential or potential energy that can be evaluated at the two positions to determine this work.
Go.
In physics, the kinetic energy of an object is the energy that is possessed due to its motion. It is
Handap.
defined as the work needed to accelerate a body of given mass from rest to its started velocity. Having gained its energy during its acceleration, the body maintains this kinetic energy unless its speed. Stephen Gary!
Ruben!
Unless its speed changes, the same amount of work is done by the body in decelerating from its current speed to a state of rest. In classical mechanics, the kinetic energy of non-rotating object of mass m traveling at a speed is in relativistic mechanics. Kat, ayusin nyo!
2, 3, go.
Mechanics, this is a good approximation only when is much less than the speed light. The standard unit of kinetic energy is the joule. Joule. Kat.